Okay, cool. Share, close, minimize, close. Okay, cool. Okay, are you guys familiar with interval notation? Okay, so it should be a review. Um, so for infinity, um, we would use parentheses, right? Well, I'll get my tools here. So, for example, if you're going towards, actually, there's not really anything to write in there. Um, anyway, if you're doing parentheses, it's definitely used for less than or greater than. If brackets used for less than or equal to or greater than or equal to. But you can't equal infinity, right? You can't equal negative infinity. So you use parentheses for those. So for example one is where we really need to make sure we're comfortable writing this interval notation. So if I were to graph these on a number line, you can put -1 anywhere, like let's say you put it here, right? And you're going to the right. Is -1 included? So you put an open circle, you shade to the right. So clear x larger than -1. Now, how would I write this in interval notation? I start from the left. I don't include the -1. And I'm going forever to the right. So forever is infinity, right? Pause infinity. And I don't put a parenthesis, I don't put a bracket, I put a parentheses, right? Because again, what is infinity? It's this abstract idea. Somewhere just keeps getting larger, right? And again, we always write from the smallest to the biggest, from left to right. So 7, I'll put 7 over here. Now, is that included? So I'll put a filled in circle. And less, I'm going to the left. Now, do I start by writing 7 or negative infinity? Because it's a lower number, right? And do I put a bracket or parentheses? Bracket, right? Now, this is everything, right? So I'm going to do this. Yeah, you could. We're going to try to get away from that though, because in AP Calculus, they don't do that. So we want to, my goal is like sort of steer in that direction, right? This is everything but 2. So I'll put a little hole there, go this way, go that way. And you guys know what the U stands for? Yeah, you're uniting both sets. Does anyone know what the upside down U stands for? Yeah, we don't really do that for this stuff, but yeah. Okay. So that should be pretty easy, pretty straightforward. Cool. Okay, domain range. Domain are going to be all valid X values. But my handwriting's not the neatest, so do not hesitate to ask me if you can't read something. You're not offending me whatsoever. And the range is all valid Y values. Anything that you can get as an output. So typically there'll be restrictions for domains, right? Like, for example, you can't divide by 0. You can't even root negative numbers. Um, so those are restrictions. Like good examples would be if you have 1 over x minus 1, x can't equal 1, right? Or here, if you have like square of like x plus 2, x has to be larger or equal to -2. Because you can root 0. That's fine. Not a problem. I'm not going to give you ones that easy. This is actually going to be probably one of the more challenging questions we'll see in this unit. And I did actually prepare an extra worksheet. So in case you just want to do more school because you just can't get enough, 5 hours is not enough of school. So when you do finish the notes, if you finish the homework, I do have an extra pack. You don't have to do it today, but you could take it home with you. That covers just this kind of stuff because domain range is a little tricky. So again, things to consider. Restrictions, find them algebraically, like if you have radicals or rational expressions. The range, you have to get a little creative. And I want you to be able to determine the range without graphing in Desmos, without graphing a calculator. Yes, should you imagine how the graph looks? 100%. But there is a, not necessarily an analytical, but a numerical way of thinking about it. And it does depend on what's going on with the function itself. Um, so we're going to have that discussion as well. So for now, we'll just talk about domain. And some of these get to be pretty fun. So this is the part that I find the most stimulating. Again, some of these should be pretty, and we're going to do interval notation. Okay, so interval notation here. And actually, this is going to help me to start remembering names. I didn't do a seating chart. Probably should have done one. Okay, Henry, right? Okay, cool. So what do you think? What do you think about part A? Sorry for putting you guys in the spot too, but we'll help you out if you get stuck. So are there any restrictions, any radicals, any denominators for part A? So if there aren't any restrictions, what are we going to say? No, what are we going to say if there aren't any restrictions? But what would the domain be? All real numbers. There we go. All real. Perfect. By the way, what kind of graph is that? With the low point of what? And while we're at it, you know what? Let's do the range. Let's do the range. So what would the range be for this one then? Yeah. And let's think about this analytically too. An expert ever hold and always rises because x squared is positive. So the lowest that y can be is 2 and it goes up forever. So you want to imagine it graphically, but also imagine it numerically too. That will help you to get a deeper understanding of how these graphs behave. Um, part B. Okay. Carlo, I'm gonna call on you next. Okay. Um, so is there a restriction for this one? What's a restriction here?
Yeah, X has to be bigger than or equal to negative.
Correct. Right. Yeah. X definitely has to be larger than or equal to. Actually, what am I doing? I told you guys to use interval notation. My bad. There we go. Now, graphically speaking, we know there's a transformation here. What kind of transformation is happening? Right. 5 left. Yeah, and a stretch too. The stretch doesn't play a role in the range, but yeah, it shifts here and rises forever. What would have to be if it's not rising, if it's falling? What would have to happen? It's got to be negative out front. It's got to be a reflection about the x-axis, right? So what would be my range here? Yeah, bracket 0 infinity, right? Now, think numerically what's happening. Roots always give positive outputs. Now we solve an equation by square rooting. That's a different story, like x squared equals 4. You solve by squaring both sides. You got to give me plus or minus. But if you're just squaring straight up, it's always going to give you a positive output. So that's positive output times 2. Of course, it's never going to be negative. It's never negative. It's going to be positive, right? So that makes sense. Okay. William, you're William, right? Yeah. So what is there a restriction for part C? So what value of x must be excluded? X can't be 3, correct? Good. So how am I going to write that? Everything but 3. So I expect the graph to look like that. You guys did these kind of graphs, right, last year? Okay, cool. Um, okay. So I think that makes sense. Um, yeah, I think that's okay. Now, let's think about the range. So all rulers except what? Zero, right? Except zero. And think numerically with top, right? So this is a division problem. You're doing one over something. The top is always fixed at one. So can the top ever be zero? No.
No.
How do you make this zero when the top is zero? It's fixed, it's stuck at one. So can I get y awfully close to zero? Sure. I can do 1/1,000,000, be like 0.001, but like, or 1/negative is negative 0.001, but I can never get to be zero, right? So yeah, sometimes you have to think a little more critically about those. So that's from -infinity to zero and zero to infinity. Abby, right? Yeah. Okay, so I'm giving you a tougher one. What are some restrictions you see here? Okay, that's one for sure. Is there more? Yeah, because you can't square at negative numbers, right? Now, I'll do the rest because it gets a little tricky here. But that's good. We see a couple of restrictions, right? By the way, A, B, and C are too easy. These weren't really what I'm talking about. So what do we do here? So definitely, so I would do like a little kind of like, what's the right word to use? Brainstorming, right? So like, okay, X can't equal 4. X squared minus 1 has to be positive. Now it could equal 0 because it's not on the bottom of the fraction. It could equal 0. That's okay. You guys remember how to solve these? Remember your name again? Phoenix, yes, go Phoenix, yeah. Right, yeah, so we have, see, it's a non-linear inequality. So you can't just add 1 to both sides and square root. Like what you're gonna have to do is factor it and create a number line. Which is exactly what Phoenix said. Exactly. So whenever it's a non-linear inequality, I strongly recommend you get all terms on one side and do some factoring. So -1 and 1 are I call my critical points because they make the expression 0. So how many? I have two partitions, but I have three intervals. An interval larger than 1, between -1 and 1, and less than -1. Well, from larger than 1, like say 2, is this valid? Yeah, 1 times 3 is greater than 0, so that's valid. From between -1 and 1, like say 0, is that valid? No. From less than -1, like -2, that's -3 times -1, that's 3. Yeah. So essentially, this would, this would check off. This would check off. That would not be okay. So right, as Phoenix said, between -1 and 1 is not okay, but greater than 1 and less than -1 is okay. Okay, so when I write my domain now, I have to, piece it all together, right? I gotta be larger than 1, less than -1, but I have to also skip over 4, right? I gotta skip over 4. So let's work our way from left to right. -infinity to what? That's my first stop. Union. Then where do I, and actually, yeah, my bad. Yeah, you're right. And then where do I pick it up again? Going till parentheses, union, or infinity. Yeah, a little tricky. Range, that's cruel. I'm not gonna do that to you guys. I won't do that. That's a little too cruel. I know it's good to talk about for A, B, and C, but yeah, yeah, I don't want to do that. Let's not do it. I'm too tired. Okay, let's do EF. Okay, so now that we're a little revved up, why don't you guys try these with the person you're sitting next to or who you want to talk to? I'm gonna do it also. Um, I'm gonna do it on my screen. I'm gonna freeze my screen. You might need about 7, 8 minutes. I don't know. We'll see. Maybe you could do faster. And no range, just domain. Don't worry about range. Just do domain. These ranges are gonna be too hard. Just do domain.
So X has to be 6 or greater. Or could it also Because if x is above negative and it's negative x times negative three, this is also it's the. As long as, well, but like, if this is negative three, yeah, and this is gonna be negative, this is stable, lines and read constant.
-3.
That's true. So it's just not
the middle section where it's
zero.
under 0, say -4.
Zero minus negative
Oh,
six.
negative, so
It
it's
would be zero, that's fine.
And actually, it can't be.
and then
Actually, they can't be like
Zero.
I do range too.
Okay, the only thing it can't be is when x is positive, but less than six. Yeah, okay, and so x has to be either equal or less than zero or greater than 2, 6. So it'd be on this, so it'd be like 2, this.
Square root of
Yeah, okay.
number 1 cannot be.
The domain be negative infinity. You're in bracket. Oh, it would just be negative.
Oh, yeah.
But it's gonna be anything less than 2.
Other ones.
You're right.
X plus
Said-
2.
So
Or it just can't be.
So,
Which means it can't be.
because then it has to be.
No.
Oh, yeah.
Yes. It can't be that, so it can't be. Negative. Two set.
I don't know, this is Joe,
He's a doozy.
Negative 5 or positive.
I mean, okay.
Well, no, let's just talk over there. And then I'll be first.
Okay, and then.
Yeah.
And then,
Yeah.
Because I think it's like.
X minus 3, X minus 1.
That means, yeah.
so.
And it can't be a negative number.
Number 5.
So
It's like 7.
Yes, 5, negative 1.
Anything above. Yeah, anything above 5. Okay, what about interviews on minus? Okay, so that's great. Right, then. It's. Wait, so it's.
Yeah.
You have two, both are flawed. Two minus 3.
I don't think it's.
Wait, no, they're negative.
Writing down.
Oh, this thing is.
Yeah, yeah.
So we'll do that.
So- X plus
Right, because
2
4 were.
is greater than.
So it can't be.
Okay, can be, so then we have, x can't equal positive or negative 5, yes. And
Okay, we'll
x
start
from, and
we'll
it's
start
negative
from
infinity. To
negative
negative 5, yeah.
Then you use.
And that is, so parentheses.
Then it goes to.
Then it goes to
Negative
Negative 1 minus.
Go to
Negative 1.
Negative 5 and 1, negative 5, 1, and brackets. No, 1 is included. Negative 1 is minus, and then 0 is equal to 0 plus 0. Union 3. Yeah, 3 in brackets.
And then you just
Yeah.
get, and then you read, and then no, then
Okay.
you go.
And then 12 minus x.
Oh.
Okay, well, can't be negative. Then go x has to be. X has to be greater than 2.
Okay.
Or x has to be less than 2. Less than or equal.
Then it's 3, which is.
And it can't be 8.
5 to infinity.
So it's less than.
And then you can.
Or it just.
The numerator does.
Yeah, I don't need
And then
it.
it's like the number, no. So the main is. Negative infinity.
Or.
8. I'm trying to get the
And this part, and I was really, that's it. We saw when we got one of.
Yeah, give me this.
number. I think that really helped. Expand.
Okay, that's.
And it doesn't do the.
You ever?
No, she sent by, eventually for another project, but she's very nice. I miss her. She would be really.
No, maybe someone else.
It's Dr.
Well.
Oh, that's true. Because of that, it's just her sister. Oh, yeah, toddler. She might have been the first name. Yeah, I saw.
I think that's kind of, I think she's been doing that.
Okay, here we go, guys. Okay, moment of truth. I could be wrong, by the way. Feel free to challenge me. Not perfect.
Okay.
But we do know for E, the only restriction is radical. I mean, specifically even root. And it's not linear, so I do a sign chart. And by the way, are you guys okay with sign charts, number line analysis? Okay, guys. So that will be pretty obvious, hopefully.
Okay.
For F, you gotta be a little careful because you don't want the whole thing to be zero. So I set the whole thing equal to zero, which would make it, which means 7 is not okay. And of course, the radical itself has to stay positive. So we have that. For G, you have two things going, but they're kind of disparate things. So one thing adds to the other. So you want to exclude 5 and -5 and also keep the radical positive. But as you piece it all together, we got to skip over -5 and 5. So you should get that. H, you're going to get two kind of disparate things. Got a radical minus of rational expression. Of course, x can't be 8. The radical is going to be greater than or equal to 0. I move the x to the right side. Or if you move the 12 or divide by negative, you got to flip the inequality, whatever. X is going to be less than or equal to 12. But it's got to be skipped over. So, okay. Okay. Cool. All right. So the rest of stuff should be smooth sailing. I saw some people got a little ahead, which is good. So, you guys should be comfortable combining functions, adding, subtracting, multiplying, dividing. So for example, each's individual domains are pretty straightforward. That's going to be x interval notation, sorry. And here, that's going to be from -infinity to 4. Okay. If you're adding the two functions, that's easy. If you're plugging 3 into it, what would you say for that one? Yeah, just root 3 plus 1, right? And by the way, if I do find the domain for part A, what would that be? We know what they are individually. Phoenix, go, yeah. Yeah, somehow you gotta figure that out, right? Yeah, so definitely it's gotta be bigger than 0, but less than 4. So it's between what and what? 0 and 4, correct, right? Right. Okay. Let's keep on moving. Okay, you got one on top of the other. So that's easy. And don't worry about simplifying it, just leave it like that. That's totally fine. Of course, let's just evaluate it. That's gonna be 0 over 2. So that's 0. That's easy. Okay. So it's almost the same domain, but with a slight little wrinkle. What do you think is going to happen there? You go, Phoenix. Yeah, 'cause you can't divide by zero exactly. So definitely have to be bigger than zero and less than 4, but you don't want to include the 4. Okay. And then if I reverse it, root 4 minus x. Again, you don't have to simplify it. Plug in 2, you should get 2 over root 2. Now, in that case, it is kind of good to rationalize just to know, so you know what's going on. That's root 2. Now, what's my domain here? Zeros, yeah, exclude the 0, correct, yeah. Exclude the 0, right. Okay. Questions on that one? We're good? Okay, nice. All right. And then finally, composition of functions. And we'll do even odd functions. Did you guys do even odd functions last year? No, that's probably new. Okay, we'll save that for. Honestly, I don't want to do any more notes past page 4, so there's no need for that. Okay, so it looks a little funny. Kind of looks like the word fog. It's no, someone's probably in fog right now. It means f of g of x. So this is a symbol used for a composite. So g is the inside, and that's the outside. It's kind of like the function machine. Like you put something to the g function, the output becomes an input for the f function, right? So in this case, if your f function is e to the x, your g function is root x. If you want f of g of x, that's just going to be e to the root x power. And then there is a restriction. X has to be larger than 0 included. So 0 to infinity. But what if I reverse it? What if I do g of f of x? Now, let's think numerically here. What is e to the x? What kind of function is that? Yeah, exponential, right? It's exponential. And the base is positive. It's growth. Even if we're decayed, it wouldn't matter. The bottom line is, can the range ever be negative for e to the x? No, never. Never for an exponential unless you put a negative out in front. So can e to the x ever cause a problem for this radical? No, never. Will never. So it's gonna be all real numbers, right? So it's all real. Again, we're doing this without a calculator, right? We don't need one. We want to think deeply about these functions. Okay. I think you guys can handle example 6. Try example 6. Hmm.
So. Domain, it's just. Oh, yeah, this is, so this is just one word. And then you get to rationalize.
I don't care. Yeah, it doesn't matter to me.
It's just, it can't be. Yeah. Yeah. It goes to not. 0 to. I can't be. No, it's. G of f of x. It's just gonna be between. Wait, so if we just like solve the x plus 3, x plus 1, yeah. Maybe 1 negative 3, it can't be in between negative 3. It can't be between. Yeah. So it can be if it's negative one. Yeah, then it just zero, yeah. So. Negative infinity. So 1/square root of x squared minus 2, which is just x minus 2.
Whenever this happens, it's the number.
Yeah.
Is the play.
Wait, no, if it's,
Negative
no, if it's negative 1, then it's 1 minus 8.
in the
There
middle.
should be nothing in the middle. Sides. Wait, so it can't be, it has to be between, it has to be above, greater than or equal to 2, or less than or equal to negative 2. Okay.
Questions?
It was about the last problem when you said that just the domain didn't include 0. I put.
Oh, let's see.
Like, how did you determine the domain?
Oh, because we don't want bond to be zero.
Oh, so as long as this is zero, that's just.
Right, it has to be bigger than zero, sure.
Yeah.
Radical. For sure.
So it would just be,
No radical.
Wait,
Oh, because square root of 0 is just.
Yeah, but you can't find it.
Oh, you're, it's the denominator, so it can't be 0.
That's what we say.
Right.
Took the words right out of my mouth. Sorry, don't know. It's gonna have a big name.
No, that's the one over.
Where root of x equals yeah.
Okay, how do we feel? Feel pretty good? Yeah, so you just plug in 1 root x into the f function. Obviously x has to be more than 0, but can't include 0. So we have that. For b, you put the f into the g function. You're going to do a sign chart, kind of did in my head. And again, you don't want to equal 0 because you can't divide by 0, so you don't include -3 and -1. And c, same thing. Don't want to divide by 0, but you got to keep it positive, so you should get that. Okay, cool. Lastly, for example, 7. It's kind of a weird one. They want you to decompose it. I mean, if you wanted to. Oh, there you go. If you wanted to, you could. It's kind of weak if you said this, but you can say g of x equals x and f of x equals the whole thing. Because it's true. That is true. You're not wrong. But you're lacking creativity. I would prefer you say this, because this is also true too. 1 root x and g of x is. So you could do that, right? So that's just decomposing. Okay. So I don't feel we should do any more math today. I think this is enough. But I want you guys to work on homework, and we still have another 37 minutes. So you guys could totally knock this out. And I did say homework should take about 40-ish minutes. So homework is right here. Let me give you guys a packet. And don't worry about submitting homework just yet. I'm going to talk more about homework submission on Thursday.
Oh.
Yeah. Is that the packet of homework for the whole as well? Yes, correct.
So we can like expand.
Yeah, I will have you guys with the homework through schools, but we'll talk about things. That's quite set things up yet.
Well, I'm sure I'm a kid in the mind. I live in deep environment. I believe.
So it right says what to do. It says do 1 through 10 all, and 13 through 20 all.
Alright, this is the
Notes. I need to put in something there.
Oh, yeah, they still say.
Hold on.
Oh,
Yeah, you got yeah, you got yeah, I think someone just got my stuff all.
So this is where it's not-
Oh, yeah.
Okay.
Or just minus Michael.
Okay.
Yeah, minus Michael. The video class. Minus Michael, minus Brady. Oh, minus G is the answer. Big boy.
Yeah, the last year, I would get like lessons and a stack of homeworks and I would study and I was going through all of them.
So we're supposed to do.
Yeah, I try to read them. Yeah, I try to do that. That saves me time too. Actually, by the way, it might be really hard to do this on the worksheet itself, so you may need to use. Yeah, or separate paper. I might have some.
Do you want us to put like a top for word or do the?
I don't care, but
Wait, do we have to put it in person or do you want?
so what's the long of that? We'll talk about that too.
Don't write on the paper because you might want to use these.
I don't like when you have this.
You want to- stuff.
I see.
I see. Did Jeffrey that?
You guys, there's just a graph paper for you guys.
So, you don't give me my pens, we're not gonna.
You don't give me a ride.
Yeah,
I'm out of here.
no, bro, you're not getting right. You can get it right.
I gave